All right, so we are in our fourth unit. So we're in our inequalities unit, and we're about to start our second topic in our divider here, which is now that we've reviewed how to identify solutions and graph inequalities, we are going to solve one-step inequalities. So solve one-step inequalities. So this will be a whole lot like solving one-step equations. You're going to use some of the same skills. So we're now going to flip to the next page of our notes. And we're going to glue in the page that you got in class. So put glue on the back of the notes page. And you'll see when I flip this over that we have just one example using each operation. So addition, subtraction, multiplication, or division. All right. And I'm going to leave a little bit of space up at the top for my title of this topic. You can either write it on the paper or above the paper, wherever you feel like you have more space. So this is IN2, which is, it's also listed down below, solving one-step inequalities. I'll write it up at the top so I have a heading. So topic 2 in our inequations unit, solving one-step inequalities. And then you're going to turn your notebook sideways so that you can write. Like I said, we have examples using addition, subtraction, this is division up at the top with the fraction bar, and multiplication. So I'm going to start up the top left with addition. So these are just one step. So we're really just going to use the BOO method because the do and undo really works better if you're trying to keep track of multiple operations that you need to do. So we're just going to stick with the BOO method for this. We're going to box in our variable to solve this. So we're going to solve this. We're going to write some solutions, some non-solutions, and then using those solutions or non-solutions, we can graph it. We also can use our little trick with our inequality, with the inequality symbol to help us graph it as long as the variable's on the left. So I have x plus 5 is less than negative 18. So I'm going to start by boxing in my variable, which is x. If we do the BOO method, you box in the variable and what's with it, but there is nothing with it basically in that term. It's just the x by itself. So again, this is just the BOO method because we're only having to get rid of one operation. All right, and we want to draw our railroad tracks. And we did equations. I just did one line down. You could have drawn 2 lines for equations. I think that's how the notes video did it. For inequalities, I do want to draw 2 lines because it makes it easier for you to draw your symbol in between the lines. And it's easier to see what that symbol is if there's not a line going through it. So I'm going to draw my little railroad tracks. And I want to do the opposite operation of adding that 5 because I want to get the x by itself, just as if I was solving an equation. So the opposite of adding 5 would be subtracting 5. So I would subtract 5 from the left. I then have to subtract 5 from the right. Then I do the math on the right side and I carry down on the left what has not canceled. So that plus 5 minus 5 right here is essentially going to cancel. And I carry down the x. So I just have x. When I do the math on the right, negative 18 minus 5 would give me a negative 23. And in most cases, you are just going to carry down your inequality symbol. So I'm just going to draw a little arrow showing that I'm going to carry down that inequality symbol. So my answer, when I've solved this, is x is less than negative 23. And I'm just going to kind of box this in, make it all nice and neat for my final answer. Now, another way that I could write this, remember we do want to make sure we know how to flip the inequality around. This would be the version I want to use to graph it because my variable's on the left, but just to make sure we're comfortable with flipping our inequality, I could write the negative 23 on the left, the x on the right, and then I would have to flip my inequality symbols. So if it's chomping the negative 23, when I flip it around, it would still have to chomp the negative 23. So if x is less than negative 23, that means negative 23 has to be greater than x. So some solutions. Anything less than negative 23, so anything to the left of it on the number line. So you could have like negative 24. You could have something as far left as negative 80. Negative 30.2, I can have decimals, that's okay. Negative 23 and a quarter. That's still less than negative 23 because it's a little bit farther to the left of it on the number line. These are not the only solutions, they're just examples. So the non-solutions are things that would be to the right of negative 23 because those would be greater. So those would not be a solution for something less than negative 23. So negative 23 in this case would not be a solution. We did not list it up above because it's not less than itself. So we always want to kind of pay attention to what I'm comparing x to and either write it in solutions or in non-solutions. It's going to have to go in one or the other. So negative 23 is not a solution. So again, things to the right of it, things that are greater than negative 23 would not be solutions. So things like negative 22. This is where you have to be careful about your negatives and make sure you understand your integers, your negative integers, as far as which integers are greater or less than other integers. Any positive numbers like positive 10, have a number with a fraction, 6.5, that's positive. And let's do one more negative number. Negative, and we'll have a decimal here, 18.8. That would be greater than negative 23, so it's not a solution. So we have examples of solutions and non-solutions, and those can help you with your graphing as well. You draw your number line here. And remember, whatever we're comparing x to, we're just going to put it in the middle. Make it easy. So I'm going to put negative 23 in the middle. Again, be careful with your negative values and make sure you put the correct values on the left and the right. So to the left of negative 23 would be negative 24, right? Because that would be more negative. And then to the right would be negative 22. This does not have a line under it, so it would be an open circle. Less ink in my sign means less ink in my circle. And negative 23 was not a solution, so it's not shaded in. And then I have to decide which way I'm going to shade my number line. So you can look at your solutions and non-solutions, or you can use your inequality symbol to help you draw that arrow as long as your variable's on the left side. I'm going to look at the solutions first. So I'm going to kind of check it with that as well. So negative 24, that is a solution. Negative 24 is on the left side. Negative 22, we said, was not a solution, and that's on the right side. So I want to shade in the side that has solutions, which in this case would be the left side because negative 24 was a solution. Negative 80 would also be a solution. It's just not visible on the number line that I have right now because it would be way far to the left of it. Negative 23.25 would be in between negative 23 and negative 24. So that would make sense, again, that I'm shading on that side. So I'm going to shade in my number line with my solutions. So again, the difference between inequalities and equations is that inequalities have more than one solution and equations only have one solution. So anything that's shaded would be a solution for x. And if I look at my little trick about my inequality symbol being my arrow, it works the way this is written here because my x is on the left-hand side. So I could draw like a little line there and it would look like an arrow pointing to the left. If this is what I had, I would have to switch it around to look like this before I could use that trick. All right, I'm going to slide down to the problem below that. I have subtraction. So x minus 2 is less than or equal to negative 18. So again, this is just a one-step inequality. So it's just easier to do the boo method because I'm only having to do one step to get the variable by itself. So I'm going to box in the x. I need to draw my railroad tracks. All right, and I want to do the opposite operation. So to get x by itself, right now I'm subtracting 2. The opposite would be to add 2. And I have to do it to the other side. Okay, you can draw a line to kind of show that you have completed that step. Minus 2 plus 2 cancels. I carry down my x. Negative 18 plus 2. You can do this in your calculator or you can do this in your head. I'm adding a positive number to a negative number. It's going to become less negative. So this would be negative 16. And I just carry down my inequality symbol. So less than or equal to gets carried down. So my answer is x is less than or equal to negative 16. Again, this is how I would want it to be graphed. I could flip it the other direction if necessary, depending on what your answer choices were. So we're going to practice that. I can write negative 16 on the left, x on the right, and if my symbol is chomping the negative 16 here, when I flip it, it would still chomp it. So it'd be negative 16 is greater than or equal to x. So both ways you can write it, but this way is how you want it to help you graph. So possible solutions. So I want numbers that I could put in the place of x, numbers that are less than or equal to negative 16. So first of all, I can include negative 16 in this one because there's the line under it. It's or equal to. So I can include negative 16. Numbers less than negative 16. Okay, you'd have like negative 17, negative 18. You could have something that's just a little bit less than negative 16, like negative 16.3. Or you could have something that's a bit more negative and has a fraction, like negative 20 and a half. Okay, those numbers are all less than or equal to negative 16. So on the contrary, non-solutions. So those are numbers that are not less than negative 16 or equal to it, which means they would have to be bigger than it, right, if they're not less than it. So that would be numbers like negative 15. It would be to the right of it on the number line. Negative 14, 0. Any positive number, right? Like 28, 2 1/4. It's a positive number, right? And you could have something very, very close to negative 16, but that's still not less than it. You could have negative 15.9, okay? It's still not less than it. It's still a little bit greater than it because it'd be a little bit to the right of it on the number line. So now I'm going to draw my graph, draw my line. The number I'm comparing to x goes in the middle, so negative 16. To the left would be negative 17, so that would be more negative, and to the right would be negative 15. So, looking at my solutions and non-solutions, negative 16 is a solution, so that would be shaded in, and looking at my inequality symbol, that would also show me it's shaded in. More ink in the symbol means more ink in your circle. So I would shade in 16, or negative 16 rather, in this case. And then I just have to decide which way my arrow's going to go. So which side of my number line is going to be shaded. Negative 16, negative 17, negative 18, well, negative 16 is in the middle, but negative 17, negative 18, negative 20 and a half, negative 16.3, those would all be to the left. So those would be shaded. The ones to the right, like my positive numbers or negative 15, those would not be shaded because those are non-solutions. So whichever side of your circle your solutions are on, that's the side you're shading. So I'm going to shade again to the left. This one was a closed circle though, where the one we did before this was an open circle. And using my trick, if my variable is on the left, I can imagine this inequality symbol being an arrow pointing to the left. So it would make sense that we shaded it in the direction that we did. All right, I'm going to go up to the top right. We have a division example up top here because that fraction bar means division. So I have x divided by 9, and you can write that division symbol like the line and the 2 dots if you prefer. You can rewrite it that way, or you can keep it as is. X divided by 9 is greater than or equal to 10. So I'm going to box in my variable. So I'm going to box in the x. I want to get rid of the divide by 9. I draw my railroad tracks, okay? And a couple different ways you can undo this now, or how you can write the opposite operation. If I have a fraction like this, I normally just would write, so the opposite of dividing by 9 would be multiplying by 9. I normally just write it off to the side to kind of make it cancel like this. But if you'd rather write below it times 9, you can. It really doesn't matter as long as you show you're doing the opposite operation. I'm going to do the same thing on this side. So I'm going to multiply by 9. I'm going to draw my line to show that I've completed that step. Carry down my x. So I have x. On the right-hand side, 10 times 9 would give me 90. Carry down my inequality symbol. So I have x is greater than or equal to 90. So I'll write that a little bit neater right below that. So far, all of these examples, and actually the last one as well, do have the variable on the left side. You just need to remember that before you graph it, if it was not on the left side, you would want to switch it so that it is. I am going to practice switching this going the other direction for when I do need to switch my inequalities around. So I'm going to write this with the 90 on the left, the x on the right. And if my symbol is chomping the x to start with, it will chomp the x when I flip it. So when I flip my equation, I also flip my symbol around as well. All right, possible solutions. So again, I normally like to use the inequality where the x is on the left in order to help me figure out my solutions. You can use either or, but anything that would go in the place of x. So first of all, there is a line under the inequality symbol, so I would include 90. That would be a solution in this case. But I also would include values that are greater than 90. So 91, 92, 106, 121.4, we'll do a decimal. Something much bigger, 254, and let's do a fraction, and 3/4. Okay, that would be greater than 90. So those are possible solutions. Non-solutions, okay, so I'm not including 90. I already listed it as a solution. So numbers a little bit less than 90. I have 89.7, 89 point anything would be less than 90. 12 could include a negative number like -10, -17. And I can do another number that's positive, but is still less than 90. 57 and 4/5. We'll go back to a mixed number here that has a fraction. So all of those would be non-solutions, because if I substituted them in the place of x, it would not be a true statement. -17 is not greater than or equal to 90. All right, so we're going to graph it. Draw your line. The number that you're comparing to x goes in the middle. So 90 will go in the middle. One to the left would be 89, and one to the right would be 91. All right, open or close circle on the 90. There is a line under it, and we listed 90 as a solution. So that'll be a closed circle. So we would include 90 in a solution. And looking at my solutions, 90 is where the circle is, but 91, 92, 106, those values are to the right this time. So I would shade to the right. Whereas my non-solutions, like 89.7, 12, and my negative numbers, those would be to the left. So I'm not shading there because those are my non-solutions. And if I were to use my inequality where my variable's on the left and look at the way that that inequality symbol is facing, it's like an arrow pointing to the right. So it would make sense that I'm shading to the right as well. All right, I'm going to slide this down to the last example that involves multiplication. So I have 5x is less than 38. So I'm going to box in my variable to get it by itself. So I want to get rid of that 5 that is currently being multiplied by the x. So remember, if there's no inequality, or excuse me, if there's no operation symbol, then it's multiplication. So to do the opposite, I would end up dividing. So let me draw my railroad tracks first. You can either show division either by doing it like a fraction or just using your line and your 2 dots to show division, whichever way. So I'm going to divide by 5, right, to get it to cancel. Times 5, divide by 5 cancels. And I have to do it on the other side. So to divide by 5. Draw my line to kind of show that that step is completed. I'm going to carry down my x because that did not cancel out. 38 divided by 5. So that does not work out very evenly. I can pull up my calculator and get it cleared out. There we go. Finally cleared. All right, so 38 divided by 5, okay, gives me 7.6. It gives me a decimal. So that's okay. This is an example where some of you guys have been trying to do a lot of this in your head and say, well, 5 times what would equal 38 if we were doing our equations. Now we're doing inequalities. And you can't just substitute it in your head. You would never come up with 7.6 on your own. So you can get decimals or fractions. That's completely fine. This is why you have to understand the process so that you can find the answers without trying to randomly guess a whole bunch of times. So I would carry down my inequality symbol, just like in my other examples. So I would carry down that less than sign. So x is less than 7.6. I'm going to move this out of the way now. So x is less than 7.6. Again, I can practice rewriting it the other way in case I ever need to switch it around. So I would have 7.6 on the left, x on the right, and I would flip my symbol around as well. So it would still be chomping the 7.6, so it would become a greater than sign. So if x is less than 7.6, that means 7.6 has to be greater than x. All right, so some solutions and non-solutions. First of all, there is no line under this inequality symbol, so 7.6 is not a solution. I'm just going to jump down here and put it into non-solutions. And then we'll come up with some solutions. So values that are less than 7.6. So like 7.5, that would work. 7.4. 6.8. I have some decimals here just because we had a decimal as an answer, but you can have whole numbers too. Values less than 7.6. Negative 27, right? That would work. Okay. So anything less than 7.6. We already listed 7.6 as a non-solution because there was no line under it. But other numbers that would not be less than 7.6 would be numbers that are greater than it, like 7.7, 7.8, something much bigger, 92, 10, okay? Those would all be non-solutions. So you can, when you graph this, it's kind of up to you exactly how you want to space out your values. To keep things simple, I'm just going to put 7.6 in the middle. Normally you have integers on your number line. It's okay. I'm going to graph it with decimals because my answer was a decimal. And I'm going to go 1/10 to the left. So this would be 7.5. And 1/10 to the right would be 7.7. So it's almost like I'm treating this like it's a ruler or a yardstick where the tenths of like a centimeter would be a millimeter, something like that. All right, open or close circle. This does not have a line under my inequality symbol, and we said 7.6 was a non-solution, so it should not be shaded. So I would draw an open circle here. And in terms of graphing this, look at what my solutions are. 7.5, 7.4, 6.8, a negative number. All those values are to the left. So this will also be shaded to the left. We've only had one of these examples that was shaded to the right. My non-solutions were like 7.7, 7.8, 10. Those would be to the right, which is why they're not shaded. They're non-solutions. And again, looking at my inequality symbol where my variable's on the left side, if I were to draw a line here, it would look like an arrow pointing to the left, which is what I have on my graph. So a couple different ways to graph. You can look at solutions and non-solutions, or you can look at your inequality where your variable is on the left side to help you figure out which direction your arrow is going on your number line or which side of the number line you're shading in.